All right, lesson 15.2, graphing logarithmic functions. How is the graph of g of x equals a log base b of x minus h plus k, where b is greater than 0, related to the graph f of x equals log base b of x? We're going to look at three different graphs. The first graph we're going to look at is log base 2 of x. Now we've done 2 to the x, and we've done 10 to the x. We've also done 1/2 to the x and 1/10 to the x. We've also done e to the x. So now we're going to look at log base 2 of x, log base 10 of x. Now remember, when there's not a base here, it's automatically 10. You don't have to put a 10 there. And then log base e of x. Remember, base e is the same thing as natural log. So let's look at these three graphs on page 839. The first one we're going to look at is log base 2 of x. Now these are the points that log base 2 of x goes through. You cannot put that in your calculator. So what they've done is they graphed it for you. But this is how they got those numbers. They gave you the y values. So -1, 0, 1, 2, and 3. Gave you y values, and then this is how they came up with the x values from the y values. So if I say the base to the power, and this is going to become my power. So what is 2 to the -1 power? It would be 1/2. So that's where the 0.5 -1 came from. All right, so if I put 0 in there, 2 to the 0 power, here's the power, to the 0 power is 1. So that would be 1, 0. If I put a 1 in there, 2 to the first power is 2. A 2 in there, 2 squared is 4, so 4, 2. And then 2 cubed is 8. So those are your points right there. Now, where did they get these numbers right here? Well, they just went -1, 0, 1, 2, 3. Instead of putting them in the x value, they had to go backwards because we're doing inverse, and so they went backwards to get it. All right, so there's one graph we're going to be looking at. Let's look at now log base 10 of x. Now notice that these are just the simple equations, which means that this is the parent function of log base 10 of x. Now on here, all you're going to do is they gave you the x values on these, and so you're just going to put log of 0.1 in there. So we will do log of 0.1 on your calculator, which will give us -1. So you're going to plot that point. 0.1, -1, right there. Then we will put log of 1, which will be 0. So 1, 0 is a point. Log of 10 is 1. So 10, 1, right there. This graph goes just like this, right there. That is log base 10 of x. Now let's look at natural log of x. All right, so the first one they give me is 1 over e. So I would do natural log of 1 divided by e, which would give me -1. So I know that 1 over e is 0.368, so that's just shy of 1/2, and -1. Okay, so let's do natural log of 1 is 0. Natural log of e, remember e is second division, is 1. And e is 2.72 approximately. So I go over 2.72, which is just short of 3, up 1, right there. And then natural log of e squared is 2. And e squared is 7.39. So over 7.39 and up 2. That's what the natural log graph looks like. Okay, if you'll turn on the back of page 840, we're going to answer questions over these 3 graphs. So we'll have to kind of look back on these 3 graphs. This one is base 2, which they gave you. This one is base 10, and this one is base e, or natural log. So the domain of the first one, domain is from left to right. The graph does not go to the left of 0. So your domain on your base 10, it's the same thing. If you look at that graph, right here, it does not go to the left of 0. Let's go ahead and look at the natural log while we're here. Natural log does not go to the left of 0. So the domain on this one would be x is greater than 0, and the domain on the natural log would be x is greater than 0 also. So right here I would say x such that x is greater than 0. It doesn't touch 0. 0 is an asymptote. And natural log would be the same thing. All right, it tells us that the range on the base 2 is all real numbers. Let's look at the range here on the base 10. It keeps going down and it keeps going up, so it would also be all reals. What about here on the natural log? It goes down and keeps going up, so it would also be all real numbers. So you can write it from, that should go from negative infinity to positive infinity. So let's just write all real numbers. Right, on the base 2, on end behavior, as x approaches positive infinity, y approaches positive infinity. As x approaches 0, y approaches negative infinity. So let's look at our base 10. This one, as x approaches positive infinity, what is y doing? It's approaching positive infinity. As x approaches 0, getting closer and closer to this line right here, what is y doing? Approaching negative infinity. So that's the same. What about the natural log? As x approaches positive infinity, y is approaching positive infinity. And as x approaches 0, y is approaching negative infinity. So these would be the same. As x approaches positive infinity, y approaches positive infinity. As x approaches 0, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. As x approaches 0, y approaches negative infinity. So the end behavior on all three of these did not change. I'll give you just a minute to write that down and catch up. All right, let's look at the base 2, the vertical asymptote or horizontal asymptote. On the base 2, right here, it never touches this line right here. It gets really, really close but never touches it. There is not a horizontal asymptote, but there is a vertical asymptote at x equals 0. What about on this one? Vertical asymptote at x equals 0. And what about this one? Vertical asymptote at x equals 0. There is not a horizontal asymptote. So vertical asymptote at x equals 0. So vertical asymptote x equals 0. Horizontal asymptote, none. Same thing on the natural log. Vertical asymptote at x equals 0. Horizontal asymptote, there is none. Intervals where it's increasing or decreasing. If we go back and look at our graphs, the base 2 is increasing throughout its domain. If we look at this graph of the base 10, it is constantly going up and up and up and up and going to keep going. And this one right here is going up and going to keep going. So it's always increasing. All right, next part, the intercepts. Where does it cross the x-axis and where does it cross the y-axis? So we're looking for the x-intercept and the y-intercept. On our base 10, where does it cross the x-axis? At right there, which is 1, 0. Where does it cross the y-axis? Where does it cross this line right here? It never does because that's an asymptote. What about on the natural log? Where does it cross the x-axis? At 1, 0. Where does it cross the y-axis? Never ever. So my x-intercept would be 1, 0. My y-intercept, there is none. X-intercept is 1, 0. Y-intercept is none. Intervals where it's positive or negative. Intervals where it's positive or negative. Now remember, positive means above the x-axis and negative means below the x-axis. And we're talking about the x values. So where is this graph below the x-axis? It's below the x-axis between 0 and 1.